Now this is the chapter 5 derivations. So we have to start here derivation. So you know that y is equal to fx. This is the function of x is equal to y. So differentiate with respect to x. We are writing, and this will differentiate with respect to x. Differentiate with respect to x. Y means this is dy upon dx, and fx means f dash x, and this f dash x is the sign of the derivation. So f dash x is equal to limit h tending to 0 fx plus h minus fx upon h. This is the first principle derivation. Derivation of first principle, f dash x is equal to limit h tending to 0 fx plus h minus fx by h. By this formula we can prove like this: the d upon dx x ki power n is equal to, the answer is n x ki power n minus 1. N x ki power n minus 1 we have to prove by first principle. So we are taking fx is equal to this is x ki power n, and x is replacing by x plus h. X is replacing by x plus h. So here x is also replacing by x plus h raised to n. Fx is equal to x raised to n. This is the question. X is replacing by x plus h. So here also x is replacing by x plus h. Now these two values put into this formula, limit h tending to 0 fx plus h is equal to this is x plus h raised to n, and then fx minus sign, fx is equal to x ki power n, replacing here x ki power n by h. Limit h tending to 0 is same. Now we have to apply here the binomial theorem, a plus b. We know that this is the binomial theorem, a plus b raised to n. This is nc0 a raised to n plus nc1 a raised to n minus 1 into b plus continue dash dash dash. Same as procedure we have to apply here binomial theorem. So first of all, nc0 a raised to n, a means x raised to n, plus nc1 a raised to n minus 1 into b this is h, plus nc2 a raised to n minus 2 into b square means h square, plus continues going on to this binomial theorem, minus x ki power n, this is minus x ki power n by h. Limit h tending to 0 is same, this is cancelled, nc0 x raised to n, nc0 means 1 x raised to n and x raised to n, this is cancelled. This is this one and this one is cancelled. Remaining here, this one is remaining. Write down, this is nc1 x raised to n minus 1, and h is also taking common outside. nc1 x raised to n minus 1, h is also here common, nc2 x raised to n minus 2 h also here is common, nc3 x ki power n minus 3 h square plus dash dash by h. This h and this h are cancelled. So we get this. Now replacing h is equal to 0. Here we replacing h is equal to 0. This complete is 0. Here also h is equal to 0. This complete is equal to 0. We get this one, nc1 x raised to n minus 1. nc1 already we known in 11th class. nc1 is equal to n x raised to n minus 1. This is the formula of d upon dx x ki power n is equal to n x ki power n minus 1. Same as these are the formula we can prove by this formula. By the first principle everyone we can prove. So d upon dx sin x is equal to cos x, prove by this formula also. D upon dx cos x is equal to minus sin x, d upon dx tan x is equal to sec square x, d upon dx cot x is equal to minus cosec square x, d upon dx sec x is equal to sec x tan x. Same as d upon dx cosec x is equal to minus cosec x cot x, this is cot. D upon dx e ki power x is equal to e ki power x, d upon dx a ki power x is equal to a ki power x log a, d upon dx log x is equal to 1 upon x, and d upon dx constant, derivation of constant is always 0. The proof of this formula we can apply by this. Now I am telling the question number first. This is the question number first. D upon dx sec inside the bracket, this is the 10 root x. The derivation of sec x, look at this, is the derivation of sec x. D upon dx sec x is equal to sec x into 10x. The derivation of sec x is equal to sec x, x means this, sec x 10, then 10 x is this. So sec x 10x, the derivation of sec. Now the derivation of 10 derivation is equal to sec square root x. At last, derivation of root x means x raised to half. We can use this formula. Half, first you are taking half n, then x raised to n minus 1, half minus 1. So we get half x raised to minus half. This is 1 upon 2 root x. So again I am telling you, d upon dx sec inside the bracket 10 root x, sec x derivation, this is sec x 10x. Sec x means this, then 10x means this. This is the answer we get from here. D upon dx sec x is equal to sec x 10x, sec into this is x, 10 into this is x. And after this is the angle derivation. First we have to derivate it sec, then 10. 10 derivation is equal to sec square root x. At last, derivation of root x is equal to 1 upon 2 root x. This is the derivation of sec x inside the bracket 10 root x. Now the derivation of d upon dx sin ax plus b upon cos cx plus d. Now we have to apply here divide rule. Divide rule means, first of all, denominator. Here we take denominator. This is the denominator. First of all, denominator, and the derivation of numerator. Sin derivation cos. Look at d upon dx. Sin x is equal to cos. Sin derivation is equal to cos. Angle is same, ax plus b. Then after sin derivation is cos, then angle derivation, a constant is same, derivation of x is equal to 1, here is alone constant is 0, minus. Now numerator is same, the derivation of denominator means cos, derivation is minus sine and cx plus d. And now the angle derivation cx plus d, c means constant, x derivation 1, constant is alone, derivation is 0. Now denominator whole square, cos square cx plus d. And the solve this, the first term, this is completely same. This is minus minus plus. First of all, c here, sin ax plus b sin cx plus d, a denominator square. This is the derivation number 2. Now the question number 3, derivation of d upon dx 2 root cot x square. First of all, 2 is constant, same. The root derivation, first of all, root derivation already we have to done here. Root x is equal to, derivation is 1 upon 2 root x. So derivation of root is equal to 1 upon 2, this complete is denominator place, root cot x square, same as this. Root x derivation is equal to 1 upon 2 root x. So root cot x square derivation is equal to 1 upon 2 root cot x square. This is the derivation of root. Now inside this one derivation cot, we know that minus cos x square, and the angle is, this is x square, is the same. First derivation is root, second derivation is cot, then after x square derivation is equal to 2x. This is the derivation of 2 root cot x square. Again I am telling you, 2 is constant. First of all, derivation of root is equal to 1 upon 2 root cot x square. Then after derivation of cot is equal to minus cos x square. This is angle is same, x square. At last, derivation of x square is equal to 2 and 2. This one 2 and 2 is cancelled. Root cot x square means cos x square by sine. So we are taking, it is in the place of the denominator. When upper side goes, this is sine x square by cos x square inside the root. The formula of cot is equal to cos upon sine, and upper position, this is sine x square by cos x square, and this is minus cos x square means 1 upon sine square. This is minus cos x square means minus is taking here, and cos x square means 1 upon, here is square is there, cos x square, so we write down 2 times sine x square into 2x. Now this one is cancelled, sine x square cancel with this, we are getting root sine x square. Now multiply by root 2 upper side and lower side of multiply by root 2. So we get our answer is equal to, this is minus 2 root 2 x upon. Here is a sine x square. First of all, we are taking sine x square. and inside the root this is root 2 root cos x square and root sin x square. This is the formula of sin 2x is equal to 2 sin x cos x. So this formula we apply into the root x. Sin 2x means this is x square, and that's all. This is the derivation of this one. That's all. कितने